A-Level Pure 1 Geometric Progressions Sum to Infinity. Let's see what we mean by geometric progressions and the sum to infinity. Consider the series a half plus a quarter plus an eighth plus a 16th and so on forever. If we add them term by term as we've done below, what we get is S1 is equal to a half. Now a half can be written as 1 take away a half. S2 is a half plus a quarter, which is 3/4, which can be written as 1 minus a quarter. S3 is a half plus a quarter plus an eighth, which is 7/8, which can be written as 1 minus 1/8. S4 can be written as a half plus a quarter plus an eighth plus a 16th, which is 15/16 or 1 minus 1/16. S6 is a half plus a quarter plus an eighth plus a 16th plus 1/32, which is 31/32 or 1 minus 1/32. And if we've got n terms, Sn is a half plus a quarter and so on up to 1/2 to the n, which is 2 to the n minus 1/2 to the n, or 1 minus 1/2 to the n. As n gets larger and larger, 2 to the n gets very large, so 1/2 to the n gets smaller. It gets closer and closer to 0. So 1 minus 1/2 to the n gets closer and closer to 1. We write as n arrow infinity to mean as n tends to infinity. 1/2 to the n arrow naught means 1/2 to the n tends to 0. So as n tends to infinity, Sn tends to 1. Or for short, we can even write that S to infinity equals 1. If we sum all the terms all the way up forever, then we'll find the total comes to 1. Now let's consider the geometric sequence A plus AR plus AR squared plus AR cubed all the way up to AR to the n minus 1. We know the sum of n terms. Sn is equal to A into 1 minus r to the n over 1 minus r. And also, if r lies between minus 1 and 1, then as n tends to infinity, Rn tends to 0. So, as long as r lies between minus 1 and 1, as n tends to infinity, Sn tends to A to the 1 minus 0 over 1 minus r, or Sn tends to A over 1 minus r. So we say, if r lies between minus 1 and 1, then the sum to infinity of all the terms is equal to A over 1 minus r. Let's look at an example. Suppose we've got the geometric progression 3 plus 1 plus a third plus a ninth and so on going on forever. Now if we want to find the sum of all the terms, we have the common ratio is a third. So we know if r is a third, it lies between minus 1 and 1. We also have the first term is 3. So the sum to infinity is equal to the first term 3 over 1 minus r. Now r is a third, so the sum to infinity is 3 over 1 minus a third, which is 3 over 2/3. And if we multiply the top and the bottom by 3, that gives us 9/2 or 4.5. So the sum to infinity is 4.5. So we have a formula for the sum to infinity which we should remember. Let's look at another example, example 2. A geometric progression has a common ratio of 2/5, and the sum of the first and fourth terms is 79.8. Find the first term and find the sum to infinity. Well, to solve this, we've got T1, first term, is equal to A, and T4, the fourth term, is equal to AR cubed. So we have A plus AR cubed equals 79.8. So if we factorise it, A into 1 plus R cubed is equal to 79.8. So A into 1 plus 0.4 cubed is 79.8. So A is 79.8 over 1 plus 0.4 cubed. And if we type that into a calculator, we get A is equal to 75. Now we know R is equal to 2 over 5, so R does lie between -1 and 1, and so the sum to infinity does exist. The sum to infinity is A over 1 minus R, which is 75 over 1 minus 0.4, or 75 over 0.6, which works out to be 125. So the sum to infinity is 125. Now in example 3, we're told the sum of the first three terms of a geometric progression is 68.6, and the sum to infinity is 87.5. Find the first term and the common ratio. Well, to solve this we have the sum to infinity is A over 1 minus R. So 87.5 is equal to A over 1 minus R. We're also told S3 is equal to A into 1 minus R cubed over 1 minus R. Now we can take A over 1 minus R out, and that gives us S3 equals A over 1 minus R times 1 minus R cubed. But if we consider the A over 1 minus R, above we've got that is equal to 87.5, so instead we can write 87.5. Also, S3 is 68.6, and that gives us 68.6 equals 87.5 times 1 minus R cubed. In other words, 68.6 over 87.5 is 1 minus R cubed, and 68.6 over 87.5 is 0.784, so we have R cubed is equal to 1 minus 0.784, which means R cubed is equal to 0.216. So when we take the cube root, R is equal to 0.6. Now we know the sum to infinity is A over 1 minus R, and the sum to infinity is 87.5, so that's equal to A over 1 minus 0.6. So A is equal to 87.5 times 0.4, which means A is 35. And that gives us our answer, A is 35 and R is 0.6.